So today I want to go over basic non-charge bonding patterns that you should recognize when you're drawing simple structural formulas for compounds. So these are all going to be non-charged. So let's start off the easiest. Let's start off with hydrogen. Hydrogen can never be the central atom because hydrogen can only share one pair of electrons, and therefore hydrogen will only have a single bond. So hydrogen will only ever have one dashed line, one single bond, and that is its only bonding pattern. Next, we're going to move over to our halogens: fluorine, chlorine, bromine, and iodine. Remember that elements in the same column, same group, or the same family are all going to do the same thing. So what I say for fluorine holds true for everybody below it. And we'll represent our halogens with an X. So an X represents fluorine, chlorine, bromine, or iodine, and they all exist in group 7A. In group 7A, they only need to share one more electron, and therefore they're only ever going to have one single bond or one shared pair of electrons. But they're also going to have three lone pairs of electrons, or non-bonding pairs. So again, we have three pairs of electrons that are not being shared, but they are going to be useful once you get to organic chemistry or start looking at the physical and chemical properties of a molecule. Remember, the name of the game is the octet rule for everyone except hydrogen and helium. So when we draw these patterns, we should be able to count to 8, 2, 4, 6, 8. For hydrogen and helium, it's just going to be a duet, 2. So moving on for our halogens, we're going to go over to our group 6A, oxygen, sulfur, selenium, and tellurium. So what oxygen does, so will everyone below it. So oxygen needs to share 2 electrons in order to get its octet. So it's going to form 2 bonds. So one of the bonding patterns you should recognize from water. It'll have 2 single bonds and 2 lone pairs. So 2 single bonds and 2 lone pairs of electrons. Remember, 2, 4, 6, 8. And then the other bonding pattern that you see quite a bit is oxygen with 1 double bond and its 2 lone pairs. So 1 double bond and its 2 lone pairs of electrons. Again, what oxygen does, so will sulfur, selenium, and tellurium. Moving over to group 5A with nitrogen, phosphorus, and arsenic. So what I say for nitrogen holds true for those others. Nitrogen needs to have 3 electrons in order to gain an octet. Therefore, it's going to form 3 bonds or have 3 shared pairs of electrons. One bonding pattern you see with nitrogen quite a bit is 3 single bonds, 1 lone pair. So 3 single bonds of electrons, 1 lone pair of electrons there on top. 2, 4, 6, 8. Another bonding pattern that you've probably already seen before, 1 triple bond, 1 lone pair. So we have 1 triple bond and 1 lone pair of electrons. And then the bonding pair that you don't see quite often is nitrogen with a double bond, a single bond, and 1 lone pair. So 1 double bond, 1 single bond, and 1 lone pair of electrons. In each case, we should have 8, 2, 4, 6, 8. The octet rule is being obeyed. Now let's get to carbon and silicon. So what I say for carbon also holds true for silicon, and you'll spend an entire course called Organic Chemistry studying the bonding patterns of carbon. But let me introduce you to the 4 common non-charged bonding patterns for carbon. So your first typical bonding pattern is carbon with 4 single bonds. 4 single bonds, 2, 4, 6, 8. Carbon with 2 double bonds. Not one that you see too often, but you will see it in OChem. So we have 2 double bonds. No lone pairs again. Another bonding pattern you see often with carbon is a triple bond and a single bond. So 1 triple bond and 1 single bond. Very typical pattern. And then the last one, very important one, carbon with a double bond and 2 single bonds. So 1 double bond and 2 single bonds. And you'll see this quite a bit in OChem and in biochemistry. So all of these bonding patterns fit the octet rule, 2, 4, 6, 8. All these bonding patterns are non-charged, so we're not dealing with anything that's going to have a charge. And I'll have another video when we look at charged bonding patterns.